Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called missing ranges. So we were given an inclusive range from lower to upper and a sorted unique integer array nums, where all elements are within the inclusive range. A number x is considered missing if x is in the range from lower to upper, but it is not in nums. Return the shortest sorted list of ranges that exactly covers the missing numbers. Okay, so that's pretty intuitive. Let's see an example here. So we're given an input like this, and the lower bound is 0, the upper bound is 99. So what are we missing? We have a 0 here, okay? And we have 1, but we don't have 2 in between 1 and 3. So we're going to add 2 to our final result. And from 3 to 50, we're missing 4 to 49. So we're going to add those into our final result. After 50, we have 51 to 74 missing. So we have this. And after 75, we got 76 to the upper bound missing. So that's our final result here, okay? And for this one, nums, there's only one element, and the lower bound, the upper bound, they're the same thing. So we just return nothing because we're not missing anything, okay? So how should we solve this problem? This is pretty intuitive. We have several information. So the first information is the input is sorted. Okay, so we don't have to sort it to get the results. Okay, second, as we walk through the solution here, we're comparing the first element with the second element. Okay, if the difference between these two is less than or equal to 1, we don't do anything because we're not missing anything. But if the difference is larger than 1, that means we missed something, and we're going to add that to our final result, and so on and so forth. And for the last element, we have to compare it with the upper bound to see if there's missing values. Also, for the first element, we have to compare it with the lower bound to see if there's any missing things. Okay, so that's pretty intuitive. So let's code it out. We're going to have a list of integer. I'm going to call it result, and after that, let me initialize n equals to num.length. I think we're going to use it since we're traversing through the array. Okay, and so let's talk about the first scenario. If n equals to 0, so if it is 0, that means we don't have any number here. So the missing range will be from lower to upper. So we're just going to add that to our final result as list from lower to upper. Okay, and return the result. Other than that, we are doing the traversal from left to right. Okay, so if lower is less than nums 0, because we're sorted, we're going to add lower to nums 0 minus 1 to our final result. Okay, so add arrays as list from lower to nums 0 minus 1. Okay, and after that, we can iterate through the whole array, n minus 1. We're going to leave the last element to compare with the upper bound. Okay, so if nums I plus 1 minus nums I is less than or equal to 1, so we don't do anything because we know there's nothing missing. Else, we're going to add nums I plus 1 to nums I plus 1 minus 1 to our final result. Okay, After that, we're going to compare nums n minus 1 to upper. Okay, so if that is the case, we're going to add nums n minus 1 plus 1 to upper bound. Okay, so yeah, that pretty much concludes everything. So we're going to return the result at the end. Let's see. Okay, I think it passes the test cases. And let's analyze the complexity here. So basically we're traversing the whole array only once, so it's going to be on. And for space, it's going to be 1 because we're not using any extra data structures to save anything. Okay, let's submit it. Cool, it passes all the test cases. Thank you so much for watching, and if you like the video, please like and subscribe to my channel. I'll see you in our next video.